Hi everyone, welcome back to my YouTube tutorials on geospatial data science. In today's episode, we are going to create a minimalistic map where I will process a global population raster dataset and then turn it into an ASCII art map. In this map, every single visual component is going to be an ASCII character, such as the @ or the hashtag symbols, and as you will see, they are going to visualize nicely and in a very old school design population level all across Europe. Let's see how this works in Python. Once again, here we are building a minimalistic population map where we are following the good old days of the so-called ASCII art. So we are going to draw the map by using different alphabetical characters, and each character will correspond to different population levels all across Europe. So first things first, we will need to get a Europe level population map. Here I'm going to build on a couple of things I put together and displayed in a few LinkedIn learning courses. So you will see how exactly we can download relevant GHSL population data in this tutorial in my Advanced Geospatial Data Analytics course, while I will show you how to download, and I'm not going to rate it now, and I'm going to show you how to prepare the Europe-wide polygon dataset based on and using natural earth as an input. And finally, I will also show you how to properly use H3 in Python, also in my Advanced Geospatial Data Analytics course. So after you check these videos out and you are familiar with how they work, let's import the usual stuff here from NumPy to GeoPandas, from raster.io to rasterstats, which is going to be useful for computing zonal statistics. Make sure that you have this split poly to hexagons function from the advanced course. Then let's go and start with the admin boundaries and see how our European map looks like. Again, this is the file which I created and prepared in the machine learning course, which contains all the European countries coming from natural earth at a spatial resolution or boundary resolution of about 10 meters. Then I will add two more steps because now we will only need Europe as the boundary polygon. So we will only need the continent boundaries, not the country boundaries. So we will use the unary union function, which will dissolve the boundaries between countries, and we will end up with one single polygon, or well, in this case, multi-polygon for Europe. We can also query the multi-polygon directly and show it in the way Shapely would show it. So that's it for the boundaries. Now let's turn them into hexagon grids. And the reason we are moving on to hexagons is because we want to place alphabetical characters on a map. And to do so, we will need a discrete number of spatial units spread across Europe relatively evenly. And to do that, doing spatial indexing, so first splitting Europe, this giant multi-polygon, into a set of well-defined hexagons is a good first step. And then when we take the central location of every hexagon, then we will have a nice evenly spread point dataset all across Europe. And after that, we will only have to do one thing: place the ASCII characters at the central locations. So let's build our hexagon grid. Here I will use Uber H3 at resolutions 3. And then do a simple plot, usual matplotlib stuff. I will color the hexagons light green. We will also draw the boundaries of Europe, just in case. Yeah, the hexagon boundaries are not that visible on this screen, so let's increase the width and let's color them red, just for the sake of an example. Yep, so there is the hexagon grid. You can see that some smaller islands are missed, But for now, we will move on with this one, and we will call this an approximation population map. So we will discard areas below a certain physical size, which is roughly the same size as the area of these hexagons. And now we move on and read in our first raster population data, which again is coming from the global human settlement layer and is covering population levels from 2025. Remember, GHSL is coming in 5-year epochs. Also, we are using the 4326 projection at a resolution of 30 arc seconds, which should be roughly around 1 kilometers. Then we will compute the zonal statistics. So we will use this hexagon grid, this red grid, as a mask or a template. And we will match that template on the raster grid directly. So we don't even need to read the raster file directly. We will just let the computations be handled behind the scenes. And then we will take the sum of all matching pixels within each hexagon. So once again, zonal stats matches every single hexagon to the pixel level population grid, assigns the pixels to each hexagon, and then takes the sum of the pixel values. So once we do that, we can actually match that back into the hexagon grid, because here this will be just a pandas data frame, if I'm right. So yeah, here the result is actually a list, but following the order of the records in the hexagons data frame. So now we can map it back to the hexagons geodata frame and also quickly visualize it. So we will have a nice Europe level population map showing the population of every hexagon. And here you can see what we would expect. For example, England or Western Europe, Germany, or this northern part of Italy are the most populated parts. And here up in the north in Norway, there are loads of very rarely inhabited areas. And we can also scale this figure down a little bit. So now we have a nice hexagon map and population values. So in the next few steps, we will replace every hexagon grid, every cell, by its centroid. So this will turn into a point map. And also every color, so every population level will be replaced by an ASCII character. So let's see how that will happen. So first we will have these characters from an empty character to point, semicolon, dash, plus, hashtag, and finally the @ symbol. Each of them sort of hinting that the more ink we use to draw these characters, the higher the corresponding population level. Next, as here we have about 7 characters, actually 10 characters. Let's split the hexagon values into these characters and then map each ASCII character to the hexagons directly. So after having a quick look, now we will see that here is the ASCII character column, which is essentially a discrete binned mapping of the population sum column. And we also have a new geometry column containing the centroids. So here we will move away from the GeoPandas plotting structure and use a more simple, more elementary or fundamental or basic plotting in Matplotlib. Let's see, this figure size is a bit too large. Let's go for this one. And in that plotting scheme, we will need to iterate over every single record in this data frame. Where we will take the centroid X and Y coordinates as well as the ASCII character from every single row. And then we will simply write out texts on the canvas. The location will be defined by the centroid, The text will be defined by the ASCII character, and then we will do some simple formatting here, font size and color. We can even turn it boldface, and then let's see how it looks like. If we want to run it first, as it is now, we will run into an error, so let's just restrict the image and make sure that we are not trying to visualize or force Matplotlib to visualize points which may fit outside of its, let's say, comfort zone. Also, this should be just 6 in both directions, and we can also set the weight to be bold. And by completing these few steps and adding the final touches, maybe bold is, or we already have a Europe map showing the population levels with ASCII characters. So good for us. We already have a nice minimalistic map of Europe, but we are not stopping here. So let's see how we can color this in some nice and minimalistic and also pretty old school or old-fashioned way. For instance, we can color it in a color theme aligning to the old DOS operating system, which for some of you who might be too young for that will not really ring a bell, will just look very old school, but we will do it anyways. So yes, so once again, I have my code prepared on my other screen, which has much larger resolution, so that's why I always have to fine-tune the figure size here. But yeah, this is how Europe would look like in an ASCII population map in this sort of DOS-like structure or style. And maybe a bit smaller fonts for this image size. Yep, there it is. And we can make it even nicer by creating a unique color map. So we won't just use the symbols, but also the colors to illustrate population levels to get a bit more colorful. Again, we will need to create bins on the data, but you can also map the characters directly to different colors, especially if you give them like order numbers, so you rank them at the very beginning. Then in the same turn, we will add the ASCII characters to make sure that they are aligned well, and then the colors. And let's see if we have the centroids stored here already. Yeah, we have it here. Then we can go for the figure creation part. And now we will simply use the color column where we have the RGB code and maximum, so minimum opacity. So if we change this from 1.0, then we can add opacity to the characters. But for now, we don't really want to do that. We want to have a nice, vivid map. And now there is an error. So that's, again, the boundary limits. So let's just set it right. Oh, it's there, but before I spoil it, I also add the title real quick. Maybe shorter. Yep. Maybe I will break this into 2 lines and increase the font size a little bit. Yep, so there it is. Okay, so pretty nice. So this is my take on this year's 30-day map challenges minimalistic map. A Europe level population map which comes in raster, then gets turned into Uber hexagons, and then gets turned into this funky old school ASCII art styled map. So I hope you enjoyed following this tutorial, and make sure you test this methodology and draw other fancy ASCII maps and let me know how they go. Thanks for following and see you next time.